Hey guys, you are going to need your note sheets over forensic anthropology, and you are going to need a highlighter. So make sure you have both of those things, and then we will get started here in a bit. Right, here's our copyright as always. So our base topic is going to be forensic anthropology, but in it we will touch on the science of death. We will talk about forensic odontology, which you've seen a little bit of when we did impressions, and we will also talk about forensic entomology, which deals with the insects that one can sometimes find on a skeleton or on human remains or a carcass. So starting with our working definition, you're going to highlight what I underlined. Forensic anthropology is the study of human remains. Sometimes they're skeletized, sometimes they're not. It just kind of depends. Most often the anthropologist deals with the bones, however, but they can work with parts that have tissue and fleshed out sections as well. They also look into the time of death, depending on what state the body is in. It's an anthropologist's job to establish the identity of the person and also the cause of death, depending on if it's like a physical nature. If it's more of a chemical nature, some kind of drug or that kind of thing, then that's often done by a toxicologist or the medical examiner. But anthropologists can be very helpful in looking at the physical makeup of the body and physical damage and injury to that body. Okay, so I'm not going to wait tons of time on each slide. I'm going to kind of pause. So if you need the video to be paused at that point, you should kind of say something, and then I'm going to move on. So the primary things that an anthropologist can identify based on the remains found would be things like age. Whoops, sorry. Let's try that again. It would be things like age, the sex, meaning male or female, the race, the potential height of the person, that's within certain amounts of accuracies, pathologies, which just means illnesses or diseases that may be present or may have been present before death or even after death, and any trauma that the body has sustained. And that trauma they can normally identify as being prior to death or after death. So part of the condition of being a vertebrate, meaning any organism that has internal skeleton or bones of some sort, means that lots of things have bones, and quite a few different animals have bones that are similar in the general appearance and size and weight and shape to human bones. So when bones are found, it's very important that a forensic scientist, or in this specific case a forensic anthropologist, doesn't just assume that the bones are human. So some of the things that they first look at is, first of all, are we looking at actual bones, or are we looking at some other kind of material? And when we do our labs over these, you're going to see that it's possible to make replicas of bones out of plastic and rubber type materials that look very realistic, depending on, if you can look at them or if you can reach out and touch them, but they may appear to not be human when you get up close and personal. So that's one of the first things that we're looking at. Are these actual bones? And if they are, the next thing we're going to ask ourselves is, are these bones human bones? Because like I said, there are several animals whose bones mimic ours, both in appearance and shape and weight and all of that. The next thing that they tend to look at is, do we have multiple victims present? Is there one individual, or is there more than one individual? How many bones are we seeing? So generally speaking, if you come back with 4 femurs, that suggests that you may have multiple people, seeing as how we each only have 2 legs and we should only have 2 femurs. The other thing that you're going to look at is, how long have the bones been there? How long have they been exposed to the elements? Can they show signs of being there for an overly long time based on their appearance, or do they look like they were recently deposited, buried, whatever? Then from there, we look into the cause of death. Potentially the bones can give us some insight, even if it can't tell us, what actually caused this person's death. Sometimes it gives us insight into the general health of the person. And then the final question that's attempting to be answered, or we're attempting to answer, would be, who do these bones belong to? Who is this actual person? What is their identity? So from this point, we are going to step through some of the things that anthropology can tell us. And we're going to start with age determination. So before I start talking about age determination, let's talk about how bones develop a little bit, and let's talk about the difference between the amount of bones you have in a very small child versus the amount of bones you have in a grown adult. So bones, a lot of your bones start off as cartilage. Think of the bendy parts at the tip of your nose and like your ears and stuff. So that material is cartilage. And over time, there are cells that will replace that cartilage with bone-like material, or the cartilage hardens and fuses into bone. So when you are first born, the majority of your skeleton is this cartilage type material. And as you grow and develop, it over time hardens and turns into true bone, which you kind of keep for the duration of your life. Now, some of the bones are in sections. Like if you think of your skull, we think of our skulls as being this whole complete unit, like this big round bone that's kind of hollow in the center where our brain is. Well, when you're so I was saying, when you're a baby, your bones are actually in smaller pieces. So your skull isn't one huge bone, it's actually 3 smaller bones. Really, they're cartilage at this point, which eventually grow together and fuse. And when they fuse, they create these zigzag-like cracks that you can see on your skull, and these cracks are called sutures. So you probably noticed that some of the stuff on the slide is underlined. I was talking and underlining without actually recording, so I apologize. So now I'm going to go over it with my laser, what I need you to pay attention to. So again, the zigzag-like cracks on your skull, those are called sutures. And they start off as being separate 3 individual pieces or multiple individual pieces at birth, but as you grow older, they close up from the inside out and they fuse and turn into bone. Now, the older you are, the less visible the sutures get. So you can still see them on an adult skull, but you have to be trained to know what to look for. It's way more obvious on the skull of a younger person. Now, when you are small, like you're a toddler or a young infant, we can use the length of your long bones. Your long bones are going to be considered your femur, which would be in your leg, and your humerus, which is in your arm. So we can use the length of those bones, and we can compare them to growth curves, to pretty much charts that tell us the rate at which you grow when you're a kid. When you get older, those charts no longer work because we stop growing at a specific rate and time. So once you're past the age of 21, the age is going to be estimated using bones by looking at how much the surface of the bone has changed. If it's rougher, if it's smoother, if there are more parts and pieces, that kind of thing. So the general rule of thumb is the older you get, the more smooth your bone is. The younger you are, the more rough and kind of torn up your bones tend to look. So if you would pay attention to the picture of the skull, it's kind of hard to see. You'll see these better in lab, but right here, that's where you can see a suture. Now, if we could look at the top of the skull, there would be another suture in this area right here, and then you could see this suture on the other side as well. But that's an example of what a suture looks like. The other thing you could pay attention to is on this long bone. So this would be the femur of a small child. See how you can tell that it's like rough and bumpy looking right in this area? Now let me erase that so you can actually see it. Okay, but if you look at it, you can tell that it's rough. There's some bumpiness going on here, and you can see some of it here as well. That's another way that we can tell that we're looking at a juvenile or someone who is under the age of maturation or being mature. Okay, so the next big grouping would be figuring out the gender of this person, if they're male or if they're female. And there are several things that we will look at, several different features on the skeleton that we can look at that will help us to decide one way or the other. So starting with the male, one of the first things we can look at would be the pelvis. Now, the female skeleton is designed to deal with childbirth, which means that our pelvis tends to be larger, it tends to be more circular, and it has a bigger opening. Okay, and all of this is because, baby has to fit somewhere. So that's one of the main differences between the male and the female. If you have access to the pelvis, you will notice that the male pelvis is narrow. It has like a smaller opening, whereas the female's pelvis tends to just be overall bigger. Think of, we have hips, whereas boys tend not to have, they tend not to be as hippie. And then it has more of a circular opening to accommodate that, the head and the body of the baby. We have a series of bones that fit kind of in the middle of our pelvis at the back section. That's called the sacrum. So men tend to have a long and narrow sacrum, and they tend to tuck under, actually, like the tail end of it tucks underneath, whereas women tend to have a wider, like more flared out sacrum, and it doesn't tuck under as much. And I'll show you what I mean by tuck under on some of the pictures that are coming up. On the front end of the pelvis, where the two bones where those two bones meet, those bones, by the way, are called pubic bones. So they form an angle. And if you are male, that angle between those two pubic bones tends to be less than 90 degrees. So it's an acute subpubic angle. Whereas on a woman, the angle tends to be approximately 90 degrees, sometimes a little bit bigger than 90. So that we have what's called a wide subpubic angle. And it really just depends on age of the woman, overall health of the woman, have they given birth before, that kind of thing. For the skull, which is the next way we can tell male from female, men tend to have a larger skull overall. Please note I didn't say bigger brain, I just said larger skull. Women, on the other hand, have a smaller skull. Now, the next feature are brow bones, and I know my girls know what brow bones are, but boys may not be as familiar. So take your fingers and touch where your eyebrows are. Literally where your eyebrows are, if you push down a little bit, you should feel a ridge of bone. That is called your brow bone. It protrudes just a little bit out of your skull. Men tend to have a more pronounced brow bone, especially if you turn the skull sideways and you're looking at the side of the head. You can see where their brow pushes out and then comes back into their face. Whereas women have more of a diminished brow bone. It just doesn't push forward. It's not as obvious as the male. And then you can look at the limbs and just kind of the overall appearance of the skeleton, and you can tell that the male bones tend to be bigger, maybe kind of slightly heavier, but they look more rugged, if that makes sense. Whereas the female skeleton tends to be more slender and more graceful in appearance. So even if you laid them side by side, you kind of tell that the male skeleton takes up more space and looks bigger, whereas the female skeleton does not. Especially when you have something else to compare it to. Alright, so here I have for you a male pelvis and a female pelvis, and I'm going to show you what that subpubic angle looks like. I'm just changing the size of my pen real quick to make it more obvious when I draw. So let's start with the male. So the male is over here on the right side. If you look at it, this is your pubic bone here and here. So that's where they meet. This little thing in the middle is just a piece of cartilage, okay? But if you were to draw a line in there to there, you can tell that that's not a 90-degree angle. It's a narrow opening, okay? Now let's look at the female, which is over here on the left. Same thing. We're going to draw in these lines where the two pelvic bones meet. And you can tell right away that that's a wider angle. So that's one of the easier ways for us to tell the difference between the male pelvis and the female pelvis. You're just looking at that angle. Now, some of them are fairly close to each other, and sometimes we do have to pull out a protractor and measure, but for the most part, you can kind of eyeball it. Okay, so let's do a quick little test. Here is a pelvis. It might be very hard for you to see the protractor that's in the shot, but I'm going to go ahead and draw in the lines, and then I want you to figure out if we're looking at, whoops, sorry, just moved the picture. I want you to figure out if we're looking at a male pelvis or a female pelvis. So here's line 1, and here's line 2. Okay, and hopefully you came up with this is a male pelvis because it's not bigger than 90 degrees. So this is the top view of what the pelvis area looks like we're looking down into the pelvis itself. And I'm going to explain what I was talking about when I said that sometimes the sacrum can be tucked under or not tucked under. So the male pelvis is over here on the right. And if we look, we have bone projections right here and right here. And then here's the sacrum. And this part down here makes up the coccyx, also known as the tailbone. But you can see how it almost looks like Mickey Mouse's ears to me. I don't know, like a wonky Mickey Mouse's ears maybe. But you can tell how all of these things stick in. So really the only space available would be right here. That's not big enough for a baby's head. So this would be a boy's pelvis. Now over here we have a girl's pelvis. We still have those same bone projections here and here. It's just the bottom part of the pelvis. But look at the sacrum. You can barely see it. It's here, like right here is a little small section of it. And then this would be the tailbone. But it's so small it's hard to tell that it's there. So you have all of this space available for baby. So obviously this pelvis over here accommodates way more than this one does. So the one to the left would be the female and the one to the right would be the male. So here we're looking at the skulls. Female skull is on the left, male skull is on the right. Let me change colors right here so I can identify some features for you. Make my pen a little bit smaller. Okay, so let's start with the male. So one of the things that I mentioned is that overall bigger skull, right? Larger skull, it's more rounded. So look at that area versus that area. Then the other thing is that the male skeleton tends to look rougher, more robust. I don't really want to use the word stronger, but like it's been through more, if that makes sense. So here you can see some roughness in this area and that area. You can see that their cheekbones kind of protrude down a little bit more. They have a bigger jaw. It's more squared off. Bigger projections to the side here and here. Okay, so that's our male skeleton. Again, a roughness right there, roughness right there, roughness here and here. Now the reason some of these features are more pronounced is because that roughness is the area of muscle attachment. Your muscle has to be attached to your bone. So to do something as simple as talking or even chewing, where you have to move your jaw up and down, you have muscles that run from this region all the way under your eye socket, and they attach to your brain, kind of like that. It's a very rough drawing, you know. But for guys, they tend to have bigger muscles than we do, so it's going to pull on their muscles more, on their bone more, sorry, which makes it rougher in appearance. Now compare this to the female skeleton, or in this case the female skull. The skull's more slender, it's more almost pointy or dome-like, whereas the male skeleton, or the male skull, sorry, is more rounded. Not as much roughness, not as much wear and tear, more of a rounded jaw, smaller projections on either side. You can still see where muscle would be attached, but it's not as obvious one to the other. So let me erase some of this stuff on the male skeleton to have a comparison to show you. I need to make my eraser bigger. It's just taking too long. Ain't nobody got time for that. There we go. Okay, so look in this area right there. See how it looks all bumpy? If you look in this area of the female, doesn't look as bumpy. That's the roughness that I'm referring to. Okay, so let's look at the skull from another angle. Let's starting off with the top part of the skull. So men have more of a sloping skull. Like if you start from kind of this midpoint, if you start kind of from the midpoint, you come down, see how it slopes down at an angle, whereas women's are more straight at the front and then it gently curves back. You can tell that boys have more of a pronounced crest or bump right in this region, whereas on a girl it's kind of smooth all the way through. Again, here's another good area to look at the roughness that I keep referring to, where those muscles attach from this region all the way through. You can see how it looks all bumpy and pretty much torn up, whereas on the girl it's still there but not as big of an area. Okay, right here we have some suture marks. Notice that on the female it's harder to see those suture marks, and it's because of the muscles that attach there. They tend to be bigger on a boy. If we look at the angle of the jaw or the mandible, so men have more of a squared off jaw. They also have this notch right in this area that I'm circling with my pen, and it creates this like dip with an angle, whereas women kind of have that notch, but it's a lot smoother, not as pronounced, so it's more of a straight finish. Okay, and then if you look at brow bone, I'm going to color the brow bone in red. For guys, that would start right about here. Okay, in this region, that would be your brow bone, whereas on girls, you can see the top part, like where it circles our eye, but you don't see the back section that's into the skull as much. It's not as pronounced. Okay, so the race determination, we're going to be using the same 3 categories that we did when we looked at hair samples earlier in the school year. And those would be the areas of Mongoloid, which are your Asian or your native descent, your Caucasoid, which would be your European descent, and your Negroid, which would be your African descent. Now there are some features on the skull that repeat themselves over and over again depending on what race or what racial area or category you fall into. So if you are Mongoloid, you tend to have a flat or projected outward frontal plane of your face. So they are specifically talking about right here. See how it slopes down? Very straight. That would be your flat section. They tend to have small but rounded nasal cavities. So on this picture to the right, the nasal cavity, we're looking at the bottom part of the nose. Right here. See how it's kind of round? And right there, that's what they're referring to. Now, the reason you have that hole in your face is because the part of your nose that protrudes out of your face or off of your face is cartilage. So when you die and after you started decomposing and enough time has passed, that cartilage gets completely worn away and broken down, and it's no longer there. So that's where that hole comes from. Where your eyes sit are called your eye orbits, or sometimes they're referred to as orbitals. So for the Mongoloid race, they tend to be circular, and it's not an obvious circle, but when you compare them to some of the others that we will look like, it looks fairly circular. So here and there. So the Caucasoids would be our people of European descent. They tend to have more of a flat cranium, not as obviously rounded. They have a long but narrow nasal cavity, so it doesn't take up as much space on their nose. So when we say nasal cavity, we're looking at, whoops, sorry, I keep doing that. We're looking at this distance here to determine if it's narrow or if it's wide. Okay, they tend to have more oval eye orbits. So on the Mongoloid skull that we just looked at, the eyes are about the same distance in terms of width as they are in length. Whereas on your Caucasoid skull, it's going to be a little bit taller or, longer height-wise than they are wide. So I'm going to try and draw those in to represent for you. Okay, so see, you can tell that the width isn't the same distance as the length. So on the Negroids, which would be our people of African descent, their craniums project backward or outward. So on this left picture, this is what they're referring to, the fact that it, whoops, oh, why do I keep doing that? The fact that it slopes out that way. Okay, that would be the outward projection. They tend to have a wider nasal cavity. So again, we're looking at this distance right here. And they tend to have more squared off eye orbits. So it's not rounded because it's kind of longer. It takes up more space at the top. So if you follow, kind of like there. kind of like that. Not as obviously round, more squared off. Okay, that's the eye shape that they're referring to. So the next useful bit of information that one can gain from a skeleton would be the height of the person, the approximate height of the person. This is going to be determined by measuring the long bones and then using calculations or using equations to calculate the resulting height. And it can be fairly accurate. Let's say it gives a good ballpark figure for a person's height. The equations are going to be different based on, so I need you to know that the equations are different based on the bone that you're using. So are we using a femur, which is a leg bone, versus a humerus, which is an arm bone, or a tibia? Okay, sorry about that. Or like I was saying, a tibia or a radius. So whichever long bone you're choosing, that's going to change the equation that you use. You also have to take into consideration the race of the person, because not all of the races grow to the same height and size. And then of course we have to take into consideration the gender, because girls tend to be smaller or shorter than boys. The long bones that we typically use for these are the femur, the radius, the tibia, and the humerus. And the femur would be a leg bone, the radius would be an arm bone, the tibia would be a leg bone, and the humerus would be another arm bone. So some other determining factors, or some other things that we can tell from the skeleton, normally it's not done just by the forensic anthropologist. One of the first things, if we get a skull, with the help of both the forensic anthropologist and a forensic artist, or sometimes a forensic sculptor, they may be able to recreate the facial features based on the skull. It's called facial recognition, or sorry, facial reconstruction, sorry. And that can help us to put a face to this body, or to these set of bones, you know, and it can sometimes help with the identification if we kind of have a vague idea of what the person could have looked like in life. Another thing that we can tell, and this is done with the help of your anthropologist and also sometimes your medical examiner or pathologist, would be pathological identities. So things like any past surgeries or bones that have been broken before or had been broken recently that show healing or scarring. It's possible to sometimes tell if the victim may have sustained trauma by looking at chips or holes or cracks in the bone, or maybe even the presence of tool marks. Like if they were stabbed, sometimes you can see the glance of the knife on like a rib bone, for example. Or if they were cut up into pieces, that's kind of gruesome. You could see the markings from the saw, depending on how that person was cut. And that tells a lot about the condition that the body was in, sometimes before death, and some of the things that might have happened to it during or right after death. So one of the things that's very important to an anthropologist is to make sure that the victim's remains are treated with dignity and with respect. So there are a series of guidelines, which are called Excavation Guidelines, that kind of are followed to make sure that the exposure and the recovery of the remains are done in a way where it's both dignifying, but also it minimizes damage to the actual remains. And the guidelines will differ based on the conditions of the scene. So the way you excavate from the forest will be very different to the way you excavate from like the ocean or a river, like if the body has been underwater, or if the body was in a house or that kind of thing. It's just going to be different based on the location of the crime scene. So the following are the general steps that's always taken for the most part. You can always count on these things being done. They're the most generic of the guidelines that we have. So the first would be to remove litter and vegetation if there is any litter and vegetation present. And then to stake out and map the exact excavation area, so pretty much where there is bone or where there could potentially be bone or remains. and then you will determine the grave outline, and if that person was actually buried or, covered over, and then you would remove the soil covering. Now, the soil covering is removed layer by layer, and each layer gets sifted like through a sieve to check for any evidence or small bones or maybe even teeth. And this continues in a horizontal pattern. As the work continues and as the work progresses, someone needs to be documenting the entire time with both photography and maps and inventory, and measurements will be taken, and of course notes would be taken as well. And that will include things that may not even relate to the actual bones themselves, but it could relate and help to build the case. If you found clothing, or if you found money or drugs, or even signs that maybe the remains were disturbed, or footprints, or anything that would help to add and build to what's in front of the forensic scientist. Now, once all the bones have been exposed, they will then each be documented again separately. So you document them as they're being exposed, and then you get full pictures of them individually as well. If it's possible that everything can be fitted together, or some of them can be fitted together in approximately where they would lie on the actual body, then at some point they will do that as well. Once all the documentation has happened, they will then remove each bone separately and bag it and tag it individually. So I know we talked about odontology already when we did impressions, but we're going to see it here again because teeth are found in your mouth and they're found anchored to your mandible, which is a part of your skeleton. So here we go. So odontology, as you know, is the study of teeth, and it's also the study of bite marks for individual identification. It can help us with determining quite a few things, including estimating the age of the person by observing the teeth that you lose as children, which are called deciduous teeth, and also by looking at the patterns of wear, like how you grind or how you chew, or, have you cracked a tooth, like that kind of thing in older adults. They can be compared to dental records to make a match between this, the unknown person and records that may potentially prove who that person is. They may contain DNA. And they're harder to destroy than bone, especially in fire, because of that enamel, which is a very hard and protective covering over your teeth. And as you know, teeth marks can also be used in bite mark identifications. So now let's look into human death a little bit more closely. So if death has occurred, the following things must be determined. The first is going to be cause. Why did this person die? So are we looking at a situation where we have disease or injury that's responsible for the sequence of events that resulted in the death? So I got shot by a gun and I bled out and that led to my death, but the initial thing was that gunshot. Did I overdose on drugs and it caused my brain to shut down, or it caused my heart to shut down? But that initial, my central nervous system got depressed, but that initially was caused by the drugs. Is it cardiovascular disease, like my heart's unhealthy and it's been doing the best it can, but after a while, those parts and pieces no longer work. I can't get blood around my body the way that it should. That led to oxygen deprivation, but is the initial cause the cardiovascular disease? So what actually caused the death? So after we establish cause, the next thing that we're going to look at is manner. So your manner is pretty much the reason the cause of death happened. Is it because it was accidental? I was walking late at night, it's dark outside, I'm not wearing any bright or reflective clothing, a car comes around the corner, it doesn't see me and hits me, that would be accidental. Is it homicidal? My husband pissed me off, I shot him. Or my cat pissed me off, I killed my cat. You know what I mean? Did it happen in my home? Did I predetermine it? Did I commit to doing a certain act? Did I think it through and take the steps necessary to result in that person's death? Is it natural? Old age, I'm 105, and at some point parts and pieces wear out and they can no longer do what they're supposed to do. Is it suicidal? I don't want to be here anymore. I took my own life. Undetermined just means that there's so many sequence of events that we can't necessarily pinpoint, that we can't say it's this one thing. We can't make a reasonable conclusion that it's this one thing. So after matter comes mechanism. So the mechanism would be, and this is the forensic definition, it would be the immediate psychological derangement resulting in death. So what actually happened in your body? Did you hemorrhage to death, like you just bled out? Was it cardiac arrhythmia? The muscles in your heart could not keep up. Literally, they burnt themselves out. Okay, so what is the actual mechanism by which you died? The actual biological reason that you died is what's considered the mechanism. Upon death, the natural progression would be that decomposition follows. And there are different stages at which decomposition happens. So immediately after death, that first stage is called the fresh stage. It's immediately after death, so let us highlight or underline some things to make this a little smaller. Okay, so like I said, it's immediately after death. There is no blood pumping. So what happens is the blood is going to drain and pool and pretty much just work its way down to the lowest parts of your body, the part of your body that is the most south, if you like to think of it that way, or the part of your body that's in contact or the most acted on by gravity or is in contact with the ground. So your blood is going to pool and it's going to drain to these lower regions, and that causes what we call livor mortis. So if you turn, let's say someone died and they fell on their back and on the ground on their back and they've been lying like that for several hours, when you turn them over, you will be able to see the areas on their back where the blood has pooled and settled. And again, that's called livor mortis or lividity. Okay, now rigor mortis sets in after, and you're probably familiar with that term. Rigor mortis is the stiffening of the muscles, so you can't move arms and legs as easily. It's almost like you have to break the arm or the leg in order to get it to move. All of this happens in the fresh stage of decomposition. Following the fresh stage is the bloat stage. And in the bloat stage, all of our all of our metabolic processes are anaerobic metabolic processes. Hopefully you remember that anaerobic means without oxygen. Okay, so all of these processes cause gases to build up in our systems, and it makes the body swell or it makes the body bloat. So that is a very characteristic thing of the bloat phase. After a while, the pushing of this gas can cause fluids to leak or purge from the orifices of our body. And orifices just means opening. Okay, so eyes, nose, ears, mouth. The next step after bloat is active decay. And during active decay, you lose a lot of your body's mass. The majority of your body's mass or bulk is lost in this stage. Most of your tissues actually kind of liquefy. And this is where you get that very strong, pungent odor that's associated with death. And that odor kind of lingers. It settles in. This is also where you can see your maggots start to pupate, like they fed on whatever tissue has remained and now they've gone into that pupal stage. Then after active decay is advanced decay. So in advanced decay we have very little insect activity. We will talk more about the insect role in this when we hit the entomology section. And at this point you have very little tissue covering you, so you can start seeing bones. There's almost no tissue or flesh, muscle if you will, left on the body. And then the last stage of decomposition is what we call dry remains, and literally all that remains will be dry pieces of skin, small bits of cartilage, and your bones. And the bones are either partially or fully skeletonized. Okay, so those are our stages of decomposition. So this leads us into forensic entomology. Now, entomology is the study of insects. Forensic entomology is the study of insects and their life cycles, and it's used to determine how long a body has been deceased. So we're going to go ahead and underline some of that. So study of insects, their life cycles, and it's used to determine how long a body has been deceased. And when a dead body is present, necrophilious insects, necrophilious just means flesh eating. Let me write that in for you. Okay, so necrophilious insects will infest that body within a 24-hour period. And most of these insects are going to be insects that enjoy eating dead tissue. Some of them just enjoy eating, tissue, period. They're not super picky about it being dead or not. So the first and most common insect that's going to be found on a corpse is the adult blowfly. And this is what they look like. They have a very pretty emerald or bottle green color, and they're iridescent. So they look beautiful, but kind of gruesome. So along with the fly, you will also find eggs, because those flies are going to not just feed, but they're going to lay their eggs on that dead body. And then eventually those eggs are going to hatch and turn into larvae, and the larvae will eventually pupate and turn into pupa. And then after some time, the pupa will open up and the adult fly will emerge. Along with our blowfly, we will also find several types of beetles, and the beetles are sometimes necrophilious, but sometimes they're just predatory on other insects that are feeding off of this carcass. So we'll find different, We'll find different types of beetles, and those beetles can either themselves be necrophilious, or they can just be predators of insects that are necrophilious. Along with our beetles, we'll also find a fair amount of omnivorous insects, and our classic examples of these would be ants and wasps. Sometimes they're feeding on the body itself, sometimes they're feeding on the other insects that are feeding on the body, or insects that are in the surrounding area, so it just kind of depends. Then we can also have indigenous insects, so insects that are only found in that area, and that's normally really helpful in pinpointing finer details about the crime. So indigenous insects, and sometimes spiders, may be present. Now their presence isn't, very rarely does it have anything to do with the body itself. Sometimes it's just kind of coincidental due to location, but again, it can be a big part in figuring out where that body has been over time, especially if it's been moved. So the life cycle of these insects themselves is influenced by a lot of different environmental conditions, particularly how long they spend in each phase of their life cycle is going to be determined by things like climate and weather, the geographical location, and then any drugs or toxins present in the body, especially if these insects are using that body as a food source or they're using it as temporary housing for offspring. So all of these things, all of these things become important for figuring out the length of time that they spend in their life cycle. And that will give you some good information as to how long that body has been exposed or in that location. Alright, so at this point we are done. Here are our resources for the notes and the information. And at this point you have picked up things when you walked in, so you're going to go ahead and get started on those activities. Remember, everything gets turned into the lockbox, and I will see you soon. Bye.